if you recall that the golden rule, if you like, of probability, so the probability of event A is the number of times A occurs. Now, we quite often abbreviate number of to the crosshatch there. Number of ways A occurs over the total number of ways, or total number of outcomes. So the number of ways that A occurs over the total number of outcomes. So we've got to be able to count the number of ways that A occurs and the total number of outcomes that can happen in an experiment. So we need a couple of ways of working these two out. Now, if it's a simple situation with dice and coins and things like that, there are two standout ways of representing all the different outcomes. Now, all the different outcomes is called the sample space. And it's just jargon for probability. The sample space, all possible outcomes. Now, if you can write down all the sample space, that will give you the total number of ways you can actually work out, and you're looking for the number of ways that a certain event occurs. You can actually count up, if you know what the sample space is and you've got all possible outcomes listed in the sample space, you can quickly count the number of ways that a particular event occurs. And if you've got the sample space, you can simply just count up the total number of outcomes. So one method for doing this is what are called tree diagrams. With tree diagrams, that will give us the sample space, and it'll actually calculate different scenarios there with different types of events. So, say you've tossed two coins. Let's look at an example here. Toss two coins. Now, tossing two coins is the same as tossing one coin twice. So, tossing three coins is the same as tossing one coin three times. And you want to know what is the probability of a head and a tail. Now that's in no order. If it's written like that, that means you get a head and a tail. You could have a tail and a head, as long as you get one of each. Okay. If you were being asked what's the probability of a head and a tail in order, it would be a head followed by a tail. A head first, a tail second, something like that. So head and a tail just read as no order. It could be a tail and a head, but there's going to be a head and a tail show up. All right, so the tree diagram. Always give yourself a bit of space. We start with the root. I guess this is where the terminology for tree diagram comes in, and we've got branches. So we're tossing two coins. So we've got the first coin, we've got the second coin, and then we've got the sample space. We want to know what the probability of getting a head and a tail in any order is. So we go down a few lines, and we start with the root, and then we branch. So the first coin, what are the two outcomes that could happen with the first coin? Obviously, a head or a tail. I could have written tail, head, doesn't matter. Okay, that's for the first coin. Now for the second coin, given that there's a head on that first coin, we've got a head and a tail here as well. And if you get into the same order, you won't duplicate and have multiple entries of the same there. So we've got a head and a tail there. Now to write down the sample spaces, as I said above here, are all possible outcomes. So if we go along the top branch and keep along the top branch here, there is one possible outcome, which is a head and a head. If we go, we've already gone across the top there, but we've got here and then there, and we've got a head and a tail. Now that completely extinguishes all possible outcomes with a head on the first coin. So now we go down here, and we'll similarly go there and then there. So a tail and a head, and then a tail and a tail. So we can see the sample space. Here is the sample space. And that's all possible outcomes in this little experiment we're doing of tossing 2 coins. So we want to know the probability of a head and a tail. So we've got to count up in the sample space how many times we've got a head and a tail or a tail and a head. Well, there's a no, there's a yes, there's a yes, there's a no. So we've got 2. On 2 occasions here in the sample space we had a head and a tail or a tail and a head. And going back to our golden rule of probability, total number of outcomes on the bottom. How many outcomes in the sample space total? 1, 2, 3, 4. So 2 over 4. So equals 1 on 2. Okay. So you had another question. What's the probability of no heads? No heads. How many times did no heads? There's 2 heads, there's 1 head, there's 1 head, there's no heads. So 1 over total number of outcomes 4. And so on. Let's just do the only other possibility. So the probability of 2 heads, we've got a head and a tail, no heads, and then 2 heads. And that's that one up there, so that's 1 on 4. And if you were to add up all this, in fact, is all the different possibilities that could happen. So a head and a tail, that's those 2. No heads is that one. 2 heads is that one. So we've got the whole lot, and just as we've done in a previous little lecture, the probability when you add them all up, so you sum up all the probabilities, and we've got a half plus a quarter plus another quarter, and we'll get our 1, which is what we would expect. Just to expand this a little bit further, say this is what we call a fair coin, where we know the probability is a half and a half. If you had a biased coin, so a biased means it's not fair. The probability of one side occurring is greater than the other. So a biased coin, and probability of a head was 0.6. Probability of a head equals 0.6. And the probability of a tail, and once again there's only 2 possible outcomes that could happen, a head or a tail. So if that's 0.6, probability of a tail would be 0.4. And say you wanted to do the tree diagram for this when you once again 2 coins, so toss 2 biased coins. So we've got first coin, second coin. So once again we go head, tail. It's the same diagram as above, but I'm going to do something a little bit different. Sample space is the same. We'll just use SS. So we've got head, 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 tail, tail, head, tail, tail. Okay. Probability of a head is 0.6. So if you write your probabilities along the branches, the probability of a tail is 0.4. So this is 0.6, 0.4, 0.6, 0.4. Now, if we go along the top branches, we've got head, head, we multiply because it's this and this occurring, head and another head, so we multiply those and we get 0.36. When we multiply 0.6 times 0.6, we get 0.36. We multiply along here to get the head and the tail. It's 0.6 times 0.4, which is 0.24. And then we go tail and head. which is 0.24, and along the bottom 0.16. So we could now answer questions about probability of getting two tails, which would be this one here, a head and a tail, which would be 0.48 if you add those two together, and so on. Notice also that if we add up the probabilities, we're expecting 1, and in fact we do get it. All right, so that's tree diagrams. They're easy to do. Give yourself space. Notice that as you go further to the right, you're going to need more space because you're branching out. And it allows you to write down the sample space. And if you write the probabilities on the branches, it also allows you to work out the probability of each of the outcomes in the sample space. And that will allow you to work out all sorts of different scenarios.